Good morning, all. Good morning. Today, board may or may not be visible to you, but you will follow my instructions. Now, you open chapter 2. Bring the book. Polynomials chapter. Chapter 2. Whatever thing I have discussed yesterday, I will repeat today. Yesterday, that is not audible. So, I will discuss it again today. First, I will tell, then write on the board. When I will write on the board, it may or may not visible on the board, but you will follow my audio, and I will. I expect you will follow me. Now the number present is 20. So far as my data is concerned, is 23. I expect all should present. Sometimes I am audible, not visible. Sometimes I am visible, not audible. Due to reflection of light, the board may or may not visible clearly, but I will teach. I will give hints on the board. Don't worry about whether it is visible or not visible, but give emphasis to audio and listen mindfully. And whatever thing you want to give, good morning to all. Welcome to the chapter 2 polynomials. First, you write equal to 0. First, you write fx equal to 0. The chapter is polynomials. It is 0. This fx equal to 0 is your 0 polynomial. Your name is 0 polynomial. Next, fx equal to a and a is not equal to 0. Then fx equal to ax plus b. Here a is also not equal to 0. Fx equal to ax square plus bx plus c, a not equal to 0. Fx equal to a x square equal to a x square plus bx square plus cx plus d. In all this, first fx equal to 0, it is your 0 polynomial. Fx equal to a is not equal to 0, it is constant polynomial. Now you write side by side, it is 0 polynomial. This one is constant polynomial. Then fx equal to ax plus b is not equal to 0. It is your linear polynomial. Linear polynomial fx equal to ax plus b. Next is your quadratic polynomial. This one fx equal to ax square plus bx plus c. Here a is not equal to 0. It is your plus b. Sorry, b. It is ax cube. I mistake everything. Square you write ax cube. Fx equal to ax cube plus bx square plus cx plus d. Fx equal to ax cube plus bx square plus cx plus d. A not equal to 0. It is called cubic polynomial. These are the name of the polynomial. It is considered as per the degree. Now, note down degree of different polynomials written here. Degree. First, degree of zero polynomial is not defined. Write down fx equal to 0 is your zero polynomial. Its degree is not defined. Zero polynomial, its degree is not defined. Then constant polynomial fx equal to a is a non-zero real number. A is a non-zero. That a is a non-zero real number. It represents constant polynomial. Here a is constant. Fx equal to a means for every value of x, fx equal to a. Then next, fx equal to ax plus b. It is called a linear polynomial and its degree is 1. Fx equal to ax plus b. Its name is linear polynomial and its degree is 1. Next is quadratic polynomial fx equal to ax square plus bx plus c. That is quadratic polynomial and its degree is 2. You see this one. Then last one fx equal to ax cube plus bx square plus cx plus d. It is your cubic polynomial. Its highest degree of the variable x is 3. So its degree it is your x cube. Now these are the polynomials where we give emphasis up to cubic polynomial. Higher order polynomials are not in the syllabus. But I will write now the definition of nth order polynomial. How can you write nth order polynomial? Just you write the definition. Here I am writing and you have to follow it. Nth order polynomial. A polynomial with degree n. Write down. It is not in a book. It is not in a book. You write down polynomial of degree n or nth order polynomial. It is fx equal to, we are writing in this way, a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x n minus 2 and so on. Last two three terms you see x plus a0. Here same condition, coefficient of highest degree term is non-zero. Highest degree term means x to the power n is your an is not equal to 0. This is the given condition. An is not equal to 0. And all a1, a2, a3 starting from a0 and so on up to an are real numbers. Real numbers. But condition that only an is not equal to 0, other may be 0. An right. Sometimes I will discuss relation. First, zeros of the polynomial. What is the meaning of the zeros of the polynomial? Zeros of the polynomial means the value or values of x for which fx is 0. Fx equal to 0. All possible values of x for which fx is 0 called zeros of the polynomial. Zeros of the polynomial. See one simple example now. I am taking one simple example. Suppose fx is given as 2x plus 3. Now equate 2x plus 3 equal to 0. Then calculate x is minus 3 by 2. When x is a minus 3 by 2, then value of fx is 0. If we calculate f of minus 3 by 2, we calculate a result 2 into minus 3 by 2 plus 3. You calculate the result is coming now minus 3 plus 3 equal to 0. I mean that minus 3 by 2 due to reflection. Sometimes it is not visible due to reflection. Okay. Tomorrow I will change the place of teaching, and tomorrow I think audible and more visible. Today it is not visible, but I am observing here. It is not visible, but I think I am audible to you all. Okay. Next, how can you get zeros from the graph? A polynomial fx is given if the graph meet x-axis at different points, then you collect the x coordinates of the points where the curve or the graph meet x-axis. That is zeros of the polynomial. Zeros of the polynomial coordinate system. This is your y-axis and this is your x-axis. One curve is drawn here. You see at this point. So now at this point, suppose this point is A, this point is a and its coordinate is 3 0, 3 0, and this point is suppose 10 0. I mean the given curve meet x-axis at 3 points, so it has a 3 zeros. Suppose fx is given here, graph of this fx is given, or we are writing y equal to fx also. Y equal to fx. This one is a function of x. That is a polynomial in terms of x. You may write here fx or also px. Actually, we are taking fx in higher classes. In your class, we are writing px. Px, fx remains same thing. Here, if a graph of this polynomial is shown in the figure, and this graph meet x-axis at the 3 points A, B, C. Here you say at A, x coordinate is minus 5. At B, x coordinate is 3. At C, x coordinate is 10. So it has the 3 zeros, and zeros are minus 5, minus 3, and 10. This polynomial has 3 zeros. Another one, you see here, another one. I've drawn here a straight line. This straight line passes through the point minus 1 0 and 1 0. Sorry, 0 1. 0 1. This line passes through the 2 points here A B. Coordinate of A is minus 1 0 and coordinate of B is 0 1. But it has only one 0, as the straight line meet x-axis exactly at one point. It has only 1 0. That 0 is minus 1. Only x-axis will be considered, not y-axis. The x coordinate of point of intersection with x-axis. Now you all proceed to exercise 2.1 directly. Remaining fact I will tell you later on. Now you proceed to exercise 2.1. Proceed to page 28 of your book. Page 28. Question number 1. It has 6 bits. See the graph. Write down zeros. Now only you write question number and only answer. First bit how many zeros, second bit how many zeros. You observe minutely and write the number of zeros. Quick. Calculate the number of zeros. First, question number 1, first bit. You see, the given line is parallel to x-axis, only meeting with the y-axis. There is no point of intersection with the x-axis, so it has no zeros. There is no value of x for which fx is 0, so it has no zeros. Second one, in question number 1, second bit, you observe the graph meet x-axis at one point, so it has 1 0. Then third bit, in third bit, the graph meet at 3 points. Try to observe the 3 points, so it has 3 zeros. 3 zeros. Then fourth bit, the graph meet x-axis at 2 points, 2 zeros. Okay, those are writing answer. Very good. I'm getting your answers. I'm telling the answer. You check with me. Then fifth bit, your graph meet x-axis at 4 different points, so it has 4 zeros. And the last bit, the graph meet at, that is confusing. You tell sixth bit, at how many points the curve meet x-axis. Yes, for sixth bit, I expect answer from you all. What is the answer of a sixth bit? Now I'm getting answer from you all. Now the number present is 22. Last to last, I think 35 students are there. I think today 36 students on that day. Now gradually it reduced to 22. You all should participate. Sometimes problem may arise, visibility may be less, or net problem may occur, but you must attend the class. So now, yes, sixth bit you all have written 3. You all are correct. Now I'm reading your names. Those have already given me the answer. Ayesha, Shivashis, Ritikesh, then Jyotiraditya, Pratyusha. What names are coming? I am reading the names. I don't know whether it is your name or your parents or your brother sister's name. Manas Ranjan Das, Chandrasekhar Murmu, Shruti Baral. Shruti Baral, I know. It is your sister's name. Acha. Babita, Pragya Paramita Patri, Rashmi Misra, Mamta Bera, Subindu Mahanti, then Rentapalli, Sai, Aryan Das, Shwetupadma Behera. These are the names are visible in my live chat. So some names are not, some phones are not in your name. Okay. You all have given the correct answer, that is 3. The graph meets 3 points. First point is your intersection, but other 2 points, the graph touches the x-axis. Touches means it touches the axis exactly at 1 point. Touch means 1 point, not 2 points. So the number of points here will be 3. Now I will proceed to relationship between zeros and coefficient. Relationship between zeros and coefficient, and will give emphasis to quadratic polynomial and then cubic polynomial. First you see the quadratic polynomial, relationship between zeros and coefficients of a quadratic polynomial. Okay. One more thing I want to tell you here. When graph is given, graph of the quadratic polynomial is given, you see, suppose the graph is given like this. It is called upward parabola. This shape is called parabola. It is your parabolic shape. This shape, this is called upward parabola. In this case, suppose this is the graph of fx equal to ax square plus bx plus c. Suppose this is the polynomial. If upward parabola, then this a A is greater than 0. As coefficient of x square is a non-zero, it is either greater than 0 or less than 0. Here, in the case of upward parabola, it may be in any form, upward parabola, that A is greater than 0. In the case of a downward parabola, the case of downward parabola, then A is less than 0. Suppose here I am showing the graph. If graph is like this, if graph is in this form, downward direction, in this case, A is less than 0. I mean A is negative. Less than 0 means coefficient of x square is negative. This case coefficient of x square is positive. Now come back to the relation. That is a very simple concept. Suppose fx is a quadratic polynomial. Fx is a quadratic polynomial. A x square plus bx plus c. It is your quadratic polynomial. A, B, C. These are called coefficients. A is coefficient of x square, B is coefficient of x, and C is the constant term. A, B, C are called coefficients. Suppose alpha and beta are two zeros. Alpha and beta are two zeros of this polynomial. I mean, if fx equal to x square plus bx plus c, alpha and beta are zeros of this polynomial, then f of alpha equal 0 and f of beta, it is also 0. Okay, if alpha is 0, if beta is 0. Okay, this thing, if beta is 0 and if alpha is 0, then alpha and beta are called zeros of the polynomial. Fx equal to ax square plus bx plus c. This is your given polynomial. Here coefficients are a, b, c. Zeros of this polynomial after factorization, you can equate to 0. From each term, you will get the zeros of the polynomial. Now alpha and beta, these are called zeros of the polynomial. Zeros. These are called zeros of the polynomial. Now the relation. Write down the relation. First relation, it is sum of zeros, and second one is related to product of zeros. Alpha plus beta, it is minus b by a. Alpha plus beta means sum of zeros is minus b by a. Minus b is coefficient of x, a is coefficient of x square. Then alpha into beta. That alpha into beta is c by a. These are the two important relations. These are called alpha plus beta equal to minus b by a. Alpha into beta is c by a. These two are called relationship between zeros and coefficients, or coefficient and zeros. Now we will verify this one with a simple problem. Now I will proceed to a simple problem. You all write one simple polynomial, factorize, equate to 0, and get the zeros of the polynomial. Here I am giving one simple question: x square plus 9x plus 20. Factorize and get alpha and beta. Factorize. You will get the product of two factors by using splitting middle term. Factorize the polynomial. Equate each factor to 0. Equating each factor to 0, you will get values of x. Those values are called zeros of the polynomial. You do first. You do and write down the zeros. What are the zeros coming here? You tell me the two zeros obtained here. Factorize. Equate each factor to 0. Then tell the values of x. Each value is 1 of 0. 110. Quick. Equation is visible, I think. It is x square plus 9x plus 20. It is visible or not visible, you see. X square plus 9x plus 20. If not visible, I think I am audible. You follow my audio and do accordingly. X square plus 9x plus 20. The polynomial given to you. Use splitting the middle term and work out. And write your answer side by side so that I will see your live chat. Quick. I expect 80%. Right. Okay. Yes. Very good. Jyotiraditya given the answer first. Thank you. I have got your answer. Jyotiraditya. Correct answer. Both answers. I expect you write only answer. Not required to write x equal to or x equal this and this. Only answer. I will understood what you have written. I've got only one answer from Jyotiraditya. I expect you also calculate and tell me the values of x. Factorize by using splitting middle term or factorization. You get two values. Yes, now I'm getting the more number. Sibasis, you are correct. 2 zeros. IS also correct. Then Giri, yes. Ritikesh, then Ajas, I think. Ajasa, then Manasandas, yes. Satyusha, then Satyusha, Mosumi Kandakule, Mosumi, Suti, Aryan. Okay, you all have given the correct answer. Your correct answer is a -4, -5. Right. After factorization, okay. After factorization, you have given me the answer x equal to -4, x equal to -5. You all are correct. I am taking now alpha equal to -4, beta equal to -5. These are the two zeros. Alpha equal to -4 and beta equal to -5. Here coefficients are 1, 9, 20. I mean A equal to 1, B equal to 9 and C equal to 20. C equal to 20. C equal to 20. These are the three zeros, three coefficients and two zeros. See now the first property, first relation, alpha plus beta. Alpha plus beta equal to -4 plus -5. Your answer is coming now -9. Calculate minus b by a. Minus b by a. It is minus b by a is minus value of b is 9. A is 1. So your answer is -9. Now here -9. Here also -9. You are getting alpha plus beta is -9. Minus b by a is -9. Hence, alpha plus beta equal to minus b by a, and the relation is verified. You can write verified. Okay, this way you can write alpha plus beta, result is obtained. Minus b by a, result is obtained. Both results are equal. Hence, we conclude here that alpha plus beta equal to minus b by a. Similarly, proceed to the second property. That second property is alpha into beta, that is a -4 into -5. Your result is 20. Here C by A, C is 20, A is 1, so the result is also 20. Here the result is 20, here result is 20, means alpha into beta is 20, C by A is 20, so the result obtained here alpha into beta equal to C by A. alpha into beta equal to C by I. It improves the second relation alpha into beta equals C by I. Now you proceed to the next exercise. Exercise 2.2. Exercise 2.2. Work out question number 1, third bit. Exercise 2.2, page number 33. Page number 33. Question number 1, third bit. Polynomial given here is 6x square minus 3 minus 7x. Your instruction is find the zeros of the polynomial and verify the relationship between zeros and coefficients. Exercise 2.2, page number 33, question number 1, third bit. You do quickly. First you tell the zeros. Factorize, equate each factor to 0. Then you will get the coefficient, then you will get the zeros. Then verify the relation. Verify the relation means alpha plus beta, calculate first, then calculate minus b by a, so that alpha plus beta is equal to minus b by a and alpha into beta equal to c by a. Here a, b and c are coefficients. Alpha and beta are zeros of the given polynomial. Yes, I have already got some answers. Very good. Mosumi Kandankel, your answer x equal to minus x equal 3 by 2 and x equal minus 1 by 3. I mean your two zeros are obtained, 3 by 2 and minus 1 by 3. It is up to you. Alpha, beta, beta, alpha you can take. You check your answer. One is 3 by 2, another answer is minus 1 by 3. Okay, all are giving now the answers. Shubhendu Mohanty, Ritikesh Jena, Manas Ranjan, Aryan Das, yes, Pratyusha, Shruti, then Chandrasekhar Murmu. Okay, no problem. When I'm calling the name of your relatives, your friends, your parents, you must clear that I am telling your name. Then Pratibha, Jyotiraditya, Shwetapadma, Pragya Paramita. Okay, Babita Rath, Amya Mohanty means Adyasa. Shivashis Biswai, Mamta Behra, Rasmi Mishra, Anil Purohit. Okay, I know Purohit Babu. Okay, your daughter. Okay. Ramakrishna Nayak, Sandharani Das. Okay, you all have given me the correct answer. One of the value is minus 1 by 3. Other answer is 3 by 2. So you calculate now alpha plus beta. Then calculate alpha into beta. You check alpha plus beta is equal to minus b by a. And alpha into beta is c by a. Here a is in question. A is 6. B is minus 7. B is minus 7 and C is minus 3. You should write in the standard form 6x square minus 7x minus 3 in the standard form. Then A is 6, B is minus 7, C is minus 3. After getting all the three values A, B and C, then verify the relation. Next, you see when zeros are given, how can you write the polynomial? When zeros are given, how can you get the polynomial? In the meantime, you do one more problem. Question number 1, sixth bit. Question number 1, sixth bit you try now. Question number 1, sixth bit also you do by your own. Sixth bit. 3x square minus x minus 4. Question number 1, sixth bit. 3x square minus x minus 4. You work out, find the zeros, then verify the relation. Then I'll discuss question number 2. Before question number 2, I'll discuss some concept. After discussing the concept, I'll do question number 2. Work out question number 1, 6th bit, VI, 6th bit. I think completed most of you. Most of you have completed. Yes, you are sending the correct answer. Very good. See now, if alpha and beta are two zeros, alpha and beta are two zeros, alpha and beta, then calculate alpha plus beta and alpha into beta. Then the polynomial whose sum of zeros given, product of zeros given, then the polynomial is x square minus alpha plus beta into x plus alpha into beta, as it is applicable for any coefficient multiplied by it. Any number you will multiply throughout, the same zeros will come. You may write here k. K is a non-zero real number. K whole into x square minus alpha plus beta x plus alpha into beta. This represents a polynomial whose zeros are alpha and beta. You may or may not write k. You may or may not write this k. You know, this k you may or may not write, but your formula is x square minus alpha plus beta into x plus alpha into beta. Alpha and beta are zeros of the polynomial. Suppose zeros of the polynomial are given, alpha is given 1 and beta is given minus 3. Then write down the polynomial. If zeros of a polynomial are 1 and minus 3, 1 and minus 3, then what is your polynomial? One way, by writing this formula, you will get your answer. If you use this formula, then your answer is k into x square minus alpha plus beta. Here alpha is 1 plus minus 3 plus minus 3 means minus 3 into x plus 1 into minus 3. 1 into minus 3. This is your polynomial. If you simplify, your answer is k whole into x square. Now it is minus 3, it is minus 3. If alpha and beta given, then this is your polynomial. K is any real number. May or may not write this k, but this is x square plus 2x minus 3 is the polynomial with variable x. That variable may be y, variable may be s, variable may be z, no problem. Normally we are using variable as x. Sometimes sum of zeros given, product of zeros given, you can calculate it directly that way. Otherwise, you calculate a, b, c, then Write your polynomial that form. Ax square plus bx plus c. Use alpha plus beta is minus b by a. Alpha plus beta equal minus b by a. Alpha into beta equal to c by a. Use this concept. Calculate a, b, and c. Then put here a, b, c. You will get your required polynomial. Either you follow this way or the way I have told you here. You can get polynomials. Now you see one question. Exercise 2.2. Question number 2. See now. Exercise 2.2. Question number 2. Second bit. You see, sum and product both are given. Here sum is given root 2. Product is given 1 by 3. Question number 2. Question number 2. Second bit. Here it is given root 2 and 1 by 3. That root 2 is the sum. 1 by 3 is product. As per your instructions of the question, into x plus alpha into beta u, then that is k whole into x square minus alpha plus beta is already given. It is root 2 into x. Then plus alpha into beta. Alpha into beta is given 1 by 3. Now 3 result is 3x square whole into this k by 3 can write down constants. In such cases, you may make it as k1 up to this k1 by 3, k1 by x square. You write in this form or you can write also this form. When question number reduced, I will complete. I will close my class with 5 minutes. Now you see, equal time given to me, you know, it is 11 to 12. So I am always stick to time. I will never proceed more than or before time or after time. I will stick to time. Now some students left. Only 18 is visible here. See now, for question number 2, sum given and product given, you may follow the way I have told you here. Otherwise, you can use the method given in a book. Example 4, you can follow how to solve. Example 4, also you can solve. So, your connection is unstable. Okay. I am closing here today. Tomorrow we'll proceed. Thank you all.
And have a nice day.
Today I am closing here. Tomorrow I will proceed. I expect you should say thank you. You know, live chat. So far as attendance is concerned, I expect you should write thank you. You all should write now thank you so that I will count the number. How many present till last. Am I audible to you or not? I think I am audible. Many students have already written thank you. I expect you all should write thank you so that I will consider you are present till the end of the period. Thank you for all for your kind patience and for your attendance. I expect you should attend the next class sincerely. Now you note down the homework. Your homework is work out examples up to 4, then exercise problems and the examples given next, and they read and write the formulas you know in the chapter 9, in the polynomial chapter in standard 9. The portion completed in standard 9 will be required here, so you must cover that chapter from 9th class also. I want you all must know division of a polynomial by another polynomial. division of a polynomial is very, very important. So do some divisions. Next period I will division. I will discuss the division and then problems. And problems related to division algorithm. Okay. Now thank you all. Thank you all. Okay. Thank you all.